So good afternoon to all of you. We are starting the presentation of our session on you and the universe.
So you're on.
Yes, I'm just starting only. As you know, it's a mystery for all of us. That how the universe looks like, how the earth looks like, how is the earth moving, are we stationary or are we moving? All these are intricacies for the human being right from our birth. So I would like to unravel most of these mysteries by this session of 2 hours. To start with, we will see a video and then we'll have the discussion on it. Let us see the video.
How fast are you moving right now? You might be thinking, I'm not moving. I'm sitting here watching this video. And that's true if you're measuring your speed relative to, say, the chair you're sitting in. But what about relative to the rest of the universe? Speed can only be measured relatively. When we say a car is driving at 20 miles per hour, it's really only traveling at 20 miles per hour relative to an unmoving reference point on the Earth's surface. We don't take into account the fact that the ground is moving too, but of course it is. As we know, it takes the Earth about 24 hours to complete a rotation. The circumference of the Earth is about 25,000 miles, so if you live at the equator, you're spinning at over 1,000 miles per hour. And we're just getting started. We also know that it takes the Earth roughly 365 days to orbit the Sun. The total trip is almost 600 million miles, which means the Earth is circling at over 66,000 miles per hour. And the Sun is also moving towards other stars in the galaxy and bringing us along at about 43,000 miles per hour. At the same time, it's moving upwards relative to the Milky Way plane at over 15,000 miles per hour. In addition to all that, the Sun orbits the center of the Milky Way once every 225 million years, moving at 483,000 miles per hour to make the trip. All things considered, we're moving at about 540,000 miles per hour as the solar system. And on top of all of that, the Milky Way is shooting through the universe. If we measure the galaxy's speed relative to cosmic background radiation from the Big Bang, we find it's traveling at an incredible 1.3 million miles an hour. So you're moving on Earth, the Earth is moving around the Sun is moving around the galaxy, and the entire galaxy is moving around the universe at a combined speed of over 1.9 million miles an hour, or 530 miles every second. That means that in the time you've been watching this video, you've traveled over 60,000 miles through space.
So you have listened to the video on how fast we are moving. I don't know whether you could imagine that movement. The fastest movement normally we have on the road maybe around 150 kilometers per hour. 150 kilometers per hour is around 95 miles per hour. That is normally the maximum speed we do have. Even the most speedy train in India cannot move beyond 300 kilometers per hour. That means around 180 miles per hour. That is a speed maximum which we have seen. So we are not used to high speeds. But remember, on the Earth's surface, the Earth is revolving around its own axis, and it revolves at a speed so that the surface speed is around 1040 miles per hour. And the Earth is moving around its own axis, and again the Earth is moving around the Sun at still higher speed. The Sun is moving around the galaxy still higher speed, and the galaxy is expanding at still higher speed. All this taken together, if you add up, it comes to around 530 miles per second, not hour. 530 miles per second. That means 850 miles per second, 850 kilometers per second. I think you got the point. We move in a second 850 kilometers in the space. Do you feel it? 850 kilometers means roughly the aerial distance between Palakkad and Pune in Maharashtra. That much we travel in a second. By the time we blink our eyes, we travel this much. I think there is one Mr. Pereira, usually he used to attend here. He's working in Goa. So the movement of this speed takes only 0.8 seconds to reach from Palakkad to Goa. Just imagine how far it is. So this is the way we are moving. Then you may legitimately ask a question, why we don't sense it? Yes, our senses are very limited. The mankind, the human beings have got very limited sense. And most of the other animals living on this continent or this earth has got much less sense, but they have got differential sense. For example, in the sense of vision, some birds have got better vision than us. In the sense of sound, some animals like rats, snakes, cats, these have got, and most of the rodents who are living inside the earth, they have got much more sensitivity than us on sound. So many of the animals do have, and even J.C. Bose has proved that plants are also having senses. All the plants do have sense. They can have pain, they can have happiness. So this is all with every flora and fauna which is live on the earth. But remember, we are unable to feel that we are traveling from the whole of India. We can travel in 3 seconds at that speed. The whole of India, that is from Kanyakumari to Ladakh, we can travel in 3 seconds time if we are taking the speed of travel of Earth, Earth's surface on this universe. This is the level which we travel, and of course we always feel that we are stationary because we cannot sense the speed. And it is lucky that we cannot sense the speed. If we sense the speed, you can imagine that every moment we'll feel that we'll be thrown out on off this earth. So it is better. It's a nature's gift that we are unable to sense the speed of the surface of Earth, which is 530 miles per second or 850 kilometers per second. So this is the speed at which we travel. I think you got the sense of how we travel. And of course, there is also another paradox. Say the Earth is globe. Earth is actually is a spheroid. It is called oblate spheroid, like the shape of the orange. It's not exactly sphere. A sphere with two ends slightly flat. That shape is called oblate spheroid. This oblate spheroid, obviously has got so uniqueness, which we'll be explaining hereafter. And one more thing is, of course, when the Earth is moving around, once we are on top of the Earth, maybe half a day after, we may be at the bottom of the Earth with head inverted. But we never feel it. We cannot feel it that because of the gravity of the Earth, we are unable to feel that we are head held high or head held down. Obviously, if the Indian is standing with the head up, definitely the American has to stand with head down and legs up. It happens, but we cannot feel it because we can feel only in a relative framework. That is what Einstein's theory of relativity says. We see everything with respect to a relative framework. And for those human beings who are standing on the Earth's surface looks flat, and we have a relative feeling with respect to that surface only. We always feel that that surface is at top, so that the opposite side of the earth, the surface may be at bottom. But anybody who stands on the earth anywhere will feel that he is standing on top of the earth, not on bottom of the earth. Now we will have some discussion about so many other aspects, and at the end of my session, I will be coming to a very controversial matter, that is whether man landed on moon. That videos and discussion I have kept to the end. So I think now you got to feel how fast you are moving in the universe, and why we feel it is stationary, and what are the limitations of the human being. And of course, when you learn the limitations more and more, you wonder at the complexities of the nature, and then you will find that there is a creator, there may be a creator, or which we don't know, but if at all there is a creator, that creator will never be able to put his or her eyes on you, because it is such a big system where a single creator will never be able to even visualize the human being on the earth. So our belief system that a God is always watching you, it's only a belief system. Whether it has something to, maybe the creator is such a superpower, we don't know whether there's a creator or not. The creator is such a superpower, we are unable to imbibe that meaning. We cannot even understand what is the depth of that creator. We will discuss all those things while we go through the remaining slides. Let us come to the next slide. Let us see what is cosmology. Whatever I am going to discuss in the first part of this session is what is called cosmology. It's a study of the universe, its structure, its origin, its evolution, its destiny. All these things will be studied in cosmology. But the limitation is most of these things are our imagination, but a studied imagination, not just a random imagination. Even now, we don't know
Sir,
what is
voice
the real
break
thing. We
అవునండి.
get some signal. I'll keep the laptop closer to me. Is it all right now? Can you listen? Is the voice breaking?
It's fine now, so it's better now.
Okay. I'll keep the laptop closer because I'm not on the video, so the laptop can be much closer. Okay. So
Okay, sir.
keep in mind that the magnitude of the Earth and universe is something which we cannot conceive, we cannot imagine, but we are studying about it. That's called cosmology. This cosmology has got a lot of realities and fiction and imagination, because you know that we can see only very short length, even with the telescopes which we have made, starting from the Hubble telescope up to the recent telescope, we are able to reach only we cannot even see things on the moon from Earth. We can see only in a big scale. We can say that so much darkness is there on the moon or something like that. We cannot see objects on the moon, so we cannot see things in the on the farther side of the universe. Especially if it is farthest of the universe, we can never see. But even then, we can see up to 10 billion light years in the universe. But we can see only the light coming from there. We cannot see how it looks like. 10 billion light years means 1 light year is the distance taken by the light to travel in 1 year. Distance by which the light travels in 1 year. Light travels in a second 3 lakhs kilometers. Roughly 3 lakhs kilometers, the light travels in a second, whereas the sound travels only 331 kilometers. See, the light travels almost 1,000 times that of the sound, 3 lakhs kilometers per second, and multiply by 60 seconds, 60 minutes, 24 hours, and 365 days, that comes to millions of kilometers. That is what is called a light year. That calculation I have shown later. I'll show how many kilometers is a light year. And such light years, 10 billion light years, 10 million light years we can see. 10 million light years far off stars we can see with our naked eye. Without any equipment, we can see with our naked eye. And remember, 10 million light years means light started from that star 10 million years back. So the light you are seeing today will be the light which started from there 10 million years back. 10 million years back, Earth was there, but human beings were not there. That light we are seeing. See the wonder? And we are seeing that light now, and because of that, we cannot know what has happened to that star right now. Maybe that star would have become a novae or supernovae or a dark matter. We don't know. I'll discuss about what is this novae, supernovae, and dark matter, dark energy, etc. I'll discuss about it. Now let us come to the next slide. Different civilizations used to denote the universe by different symbols. These are some of the symbols used by the old civilizations. But that is of no consequence now because they were not knowing really what is the universe like. They used to observe because the equipments were not there. Even the Hubble telescope was made only in the 20th century. So they were not having any much equipments to observe that. Of course, Galileo made the telescope, but that was a small telescope. With that, we could see only the solar system properly. The outer space, we couldn't. Anyway, they knew that even our own saints, say for example, I always quote it. There is the first words in the first ever Veda of Hindus, Rigveda. Rigveda starts with the origin of the universe. It says, Nasadasina sadasitadani nasidrajono vyama paroyak. That means in the beginning of creation, everything was there, but nothing was visible. Water was there, but water was not there. That means it was a form of what is called invisible plasma states. That is what the Rigveda says. And even the present theories do reinforce it. I don't know how the saints wrote it that time. How the saints of maybe 2 to 3 millennia years back, maybe even it may be 5 millennia years back, how they imagined that at the beginning of the universe, the earth was not there, the skies were not there, but everything was there in what is called a plasma stage. But they imagined that. That's pure imagination. So many civilizations, obviously, in the initial years of civilization, Indians were the best to imagine. We have imagined nuclear weapons. We have imagined aeroplane. We have imagined the origin of the universe. No other civilization has got any written treatise on these things. Obviously, even when Da Vinci was designing the aeroplane, he has taken the help of the Vedas concept which were given earlier in sketch forms on which he has reproduced. Of course, the Vedas were not available to him at that time, but he got some glimpses of its concept. That's all. Because Vedas became available to the Westerners only in the 17th century when the son of Shah Jahan, Tara, Aurangzeb's brother Tara, got the help of some pandits, Persian pandits, who translated all the Vedas and Sanskrit books to Persian, and from Persian it was translated to German and French, and that is how the Western world got to know about the Vedas and the Idihasas of Indians, which they first wondered. They were not knowing really that such a great collection of epics were available with us, scientific treatises were available with us. Now see the next slide. This was the old concept by Claudius Ptolemy. Claudius Ptolemy, there are two Ptolemies in history. One is the disciple of Aristotle, who was a philosopher. This is not that Ptolemy. This is the astronomer Ptolemy, who lived in the 2nd century AD, Claudius Ptolemy. Ptolemy has said that the world, the universe is epicenter. Epi means earth related. So earth is a center. Earth is the center of the universe, and moon is revolving around. Venus is the next, sun is the next, Mars is the next, like that. This was the concept in Indian Jyotish also. They believed that earth was the center and Navagrahas used to. That is why the Navagraha concept is there in the old Indian astronomy. You, Buddhan, Shukran, etc., you would have heard sometimes. So that is the Navagraha concept. That concept has come from the earlier belief system of Claudius Ptolemy. But remember, even before Ptolemy had this belief system, Indian astronomers like Indian astrologers like Aryabhata used to have this belief system. Maybe Ptolemy would have taken from them, I am not sure. But that has changed later. See the next slide. When it came to Copernicus in the 15th century, he was the first to postulate that the universe is not earth-centered. The universe At that time, universe to them was only the solar system. They were not aware of, they all believed that the stars which we see far away were, for example, it was believed that great rishis or great men, when they die, they become stars. That was a belief system in the Hindu mythology in the earlier stage. Also, they believed that most of the rishis used to dwell in stars. Say, for example, we have got the Rishi Saptarshi, the seven most prestigious rishis of the Hindu mythology, which we say Mariti, Angadi, Atran, Pulastyan, Pulahan, Kradu, Vasishna. All these rishis who are called the Saptarshis, they used to dwell in stars. In English, the Saptarshi is called Orion, because in the Greek mythology, Orion has got some other story. Anyway, I'm not going to that, but Copernicus first postulated that the world or the universe is sun-centered. And of course, Galileo also established it by his observations with the telescope, which he was the person who developed the telescope, and with his telescope he observed it, and he confirmed that what Copernicus said is true. But obviously Galileo was not approved by the church, and he had to apologize to the church. That is another part of the history. But by 15th century, we started believing that sun is the center of the universe. But now we know that sun is not the center of the universe. Sun is only the center of the solar system, and the center of the universe we cannot predict where it is, because the universe is so big. Let us see the next slide. This is a new theory which has come from Albert Einstein in the beginning of the 20th century. Albert Einstein says that the universe had a big bang, and from the big bang the solar system evolved. What is this big bang is, I'll tell, it's a story-like thing. We believe it, the scientific world believe it. The belief system is that stars do have lifetime, like the earth has got its lifetime. Human beings have got lifetime. The star has got lifetime. A star initially will have less light because it's in the initial stages of, either it will be, atomic, that there are two systems of the atomic reaction, the fission and the fusion. And most of the stars are fusion stars, not fission stars. So in the fusion stars, obviously, a lot of energy and light will be dissipated. And in the initial stages, the emission of the energy will be lesser. The star will not be much bright. But as the star becomes younger, the lifespan of a star, say for example, for a human being, we may say a person is a young man at the age of 18. But in the case of a star, this may be millions and billions of years. After so many years, the star becomes a younger star, and then the light will be more. And when the middle age of the star is over, again the star will depreciate, because the matter in the star will be mostly dissociated by that time. So the star will again come down in the emission standards, and of course the light emission from the star will come down. And when a star becomes old, it becomes almost reddish. And its size will reduce, because most of the matter will have been lost from the star in the form of energy. Star emits energy. At that time, that star becomes reddish, and then we call it as it's a red dwarf. Dwarf means, in Malayalam we say short people are called dwarf people. So the star becomes smaller, then we say it's a red dwarf. And this red dwarf will again become shorter and shorter by emitting. Then it has got another stage which is called, and before that I missed two stages. After the old age of the star is over, before becoming the red dwarf, it has got two more stages. That is called the nova stage and the new supernova stage. Nova stage means after much of the matter in the star is demolished, or much of the matter in the star is lost, it becomes a shining object but without much emission. That stage is called nova stage. And again, when the matter is still lost, it will have only light emission much, not other energy emission, and it will become what is called a supernova stage. In the supernova stage, it is the time for death of a star. Like the human beings have death time, the star will have a death time. And the supernova time, the stars normally have two options. First option is the star will explode. That is what is called the supernova explosion. And it will explode to small pieces. This is one case. Another case is the star will go smaller and smaller with less emission, and that is called the red dwarf. So if a star is not going to the red dwarf stage, it will explode. That is called a supernova emissions. Both of these are happening in the universe as per the space scientists. And if it goes to the red dwarf, that red dwarf will still become lesser and lesser, and it will become dark energy and dark matter. Dark matter means, when the electrons in an atom are lost, the atom has got very less space. For example, in an atom there will be you will have a nucleus, and around the nucleus the electrons will be spinning. Electrons and neutrinos, all those things may be spinning around the nucleus, but the nucleus size of the atom is so small. You would have studied the numbers that the size of the electron is how much. It will be around 1 by 10 raised to 80 into 1 by 10 raised to 22 size, the nucleus of the element will be. That means the matter can reduce to such a small level. For example, in this proportion, whatever I am saying, a human being can be reduced to the size of a small dirt in nano size. If we are removing all the atoms in our all the electrons, etc., in our atoms, if only the nucleus, that means mostly the protons only form the dark matter. So the dark matter is such a condensed matter. Say, for example, even one spoonful of that dark matter, even one spoonful cannot be lifted by even an elephant. It will be so heavy. Just imagine. And that this dark matter is highly electrical activity. It is only protons. There are no spinning electrons around. So it can absorb everything which is moving away. Say, for example, if such a dark matter is present in the atmosphere somewhere far away, it may attract even stars from far away. All the planets which are nearby, all the meteors which are nearby, all this dark matter will absorb. That is why it is called a dark hole. And this theory was promulgated by Dr. Chandrasekhar. He has done, I think you would have heard him. Dr. Chandrasekhar was the nephew of Dr. C.V. Raman. Dr. Chandrasekhar is a well-known physicist. Dr. Chandrasekhar has done a lot of his studies on this dark hole. And he has found that if a dark hole is existing in the universe, all around the dark hole, it will attract even bodies which are even light years away from that entire area. So many such dark holes are present in the universe, okay, where dark matter is there. And the dark holes, when they are present, the electron part of that will be escaping, and they also will have very less size, because in atom the vacant space is maximum. I know almost 10 raised to 18 to 10 raised to 22 times the vacant space is there. Only 1 by that much part will be the solid part, the protons or the electrons. So it shows that if the electrons are separated, their size also is very small. They becomes moving part, that is the energy, and that energy is what is called dark energy, because the dark energy content is purely electrons or such particles. And you know that if it is in an atom shape, they will have got big size. So like the dark matter, the dark energy is also highly condensed, and dark energy is such a thing which can also have the same impact. So universe is full of dark energy and dark matter at very many places. Both of them are dangerous, because dark energy as well as dark matter are very heavy. Of course, heaviness we cannot measure on Earth, because Earth we measure the heaviness based on the gravity of the Earth. But these things are outside the Earth. They are universal matter. So I think now you understood what is dark matter and dark energy. Many places in the universe, dark matter or dark energy there. And if at all you can see any such location through telescope, you can see that nothing will be around that. That will be absorbing everything which is moving around it. It's so, and so on Earth, if by chance Earth passes through the range of a dark matter or dark energy, definitely will be absorbed as a whole, like the lizard absorbing the mosquito. Like that, it will be immediately absorbed within a fraction of a second. Let us hope that the Earth will not be absorbed, and the solar system as a whole will be absorbed like that. It can happen. So because Sun is comparatively a small star, Sun doesn't have the power to resist the attraction of a bigger dark matter. That is there. Sun is comparatively a small star. Now let us come to the next slide. So don't be afraid by hearing all these things. This can happen. But remember, most of these things are partly observations, not realities. Based on what we observe in the universe, we believe that it is working like this. So this is how a supernova transforms. You see the supernova outside, still light is there. Inside the dark matter is forming, and gradually it converts entirely. It's a dying star. Dying star ultimately becomes a dwarf. You know that initially it is a white dwarf. When the light is there, it becomes a red dwarf, and from red dwarf it becomes a dark material. This is the conversion stage, what is shown here. Like the flame of a fire gradually gets lesser bright, then the flame goes off, then it becomes charcoal or ash, like that. That phenomena happens in the star. And remember, most of the stars are much higher than, much bigger than our sun. So we don't know what all places the life is existing. We cannot even imagine whether life is there anywhere else in the universe, because millions of such galaxies are there, and in every galaxy millions of stars are there, and in every star there is a possibility of many planets. And in addition to planets, in addition, some moons also may be there for all these things. Some planets may be there. So we don't know exactly. Even beyond the solar system, we don't have any idea. But we have confirmed one thing: in the solar system, right now, life is not there anywhere. Of course, in the Jupiter, studies have shown that earlier life forms should have been there, but now life form is not there. That is what the studies do say. Maybe it can be even changed, because recently only our scientists have decided that Pluto is not a satellite for the sun. Pluto is not at all a planet. It's only some asteroid or something like that. So from the 9 planets we used to have, when I was a school student, we used to study that there are 9 planets. But now the students are studying that there are only 8 planets. Pluto has been removed from the planet list, and it is given the name of some asteroid or some space material which is revolving around the sun. That's all. And also whether it is revolving around the sun, it is yet to be confirmed. It's all partly imagination. Now coming to the next. This is the, of course, I told that the initial stage of the supernova, high light is there, and in the initial stage, even some part of it can escape also. And a Big Bang happens actually at this stage. If at this stage, before the white dwarf forms, if this star is breaking, then we call it as a Big Bang. Einstein says that our sun and of course our entire solar system are the outcome of such a Big Bang. I'm not sure whether that has happened, but that is as a belief system which is going on right now. There is one more theory about the origin of the Earth, which is called the cloud theory. Cloud theory is entirely against the Big Bang theory. Big Bang theory says that a supernova exploded and gave rise to the present solar system, but cloud theory says that the plasma cloud which was there, it condensed and it became the planets and the sun. Anyway, these are all, we cannot prove any of these things. Whatever I am saying now are only belief systems. Nobody has proved. Next slide, we will see. This is the supernova turning to dark energy and dark matter, the conversion stage. Next one, please. And of course, the dark matter formation. When it becomes a dark matter, it will not retain a spherical shape or something. It can be even like a comet shape, like a kite shape. The shape may change. So that is the dark matter. It is at the end of the supernova stage. Okay, next one. Now, this is the present concept. Of course, Dr. Chandrasekhar has done a lot of study. And after that, so many other scientists also did a lot of study. And they have come to a conclusion that almost 96% of the universe is consisting of dark matter and dark energy. Only 4% is the other content. See, all the stars, all the planets, etc. are not dark. Once it is dark, means the size will reduce. I told the size will become million part. Million is 10 raised to 6. So 10 raised to 18 means 3 times million. So that is what I told. It will be only 1/millionth of a millionth of a millionth of a star, that the size of the dark matter will be. So dark matter will be very small in size, but this dark matter is almost 23% of the universe. And of course, dark energy. I told dark energy is in somewhat like an invisible crowd, just like an electron flow. It is almost 73% of the universe, and only 4% is the normal matter, like the sun, the moon, the earth, the planets, the stars, etc. Stars means visible stars. Just imagine the entire universe, 96% is invisible. Of course, the dark matter looks like a dark hole. That is why it is called a dark hole. Okay. In Malayalam, we used to call it as Tamo Gartam. Means Tamo means darkness. Gartam means, a hole, deep hole. Okay. Now let us see the next slide. So this is a recent study by NASA which says that the stars formed early than what we were thinking. We were thinking that the stars formed almost just at the time of a big bang in the universe, a big consolidation of gases in the universe. These are all imaginary theories. But now it is believed that the stars were there even before that, because we don't know who is the creator. And if at all you know the creator's calendar has nothing to do with us. Because the creator's calendar, the Homo sapiens cannot be there, because the creator's calendar is so huge in that to mark when the human beings originated by some accident and involved it cannot be marked on the cosmic calendar. It is so big. Okay. See the next slide. Edwin Hubble was the first to make a meter-long telescope. He was the first to start serious observation about the universe. Of course, Galileo made improvised telescope, but those telescopes were able to see only small spaces. But Hubble could make a bigger telescope. Nowadays, radio telescope is also there, because radio telescope doesn't see, it listens. That is the difference. Now, the most powerful telescopes now are radio telescope. A radio telescope is not like the visual telescope which we are seeing. Radio telescope is absorbing the minor sounds, cosmic sounds, and interpreting it. It's not seeing it. So most of the things which we are saying now based on radio telescope, we have not seen it. We interpret it based on the frequency of the sound it is receiving. I told that human ears cannot receive many sounds, but radio telescope can receive sounds of a bigger frequency. And of course, you know that even the visual frequency, our eyes can see only from 20 hertz to 20,000 hertz, the visible light. But of course, the radio telescope is for sound, not light, because light has got limitation. Light gets scattered, but sound, some part of the sound, of course, sound also gets scattered. But the sound transmission is also, there is vacuum all around, so the sound transmission is also very low. Cosmic rays, some of the cosmic rays are better indicators. But again, identifying the cosmic rays from where they have originated is a difficult task. So most of the studies which we have conducted about the universe are either based on studies of the cosmic rays or the cosmic sounds, which is by radio telescope. And the visible spectrum studies are still limited. What can be seen through an optical telescope, even the Hubble telescope or improvised Hubble telescope, is very limited. So man's power to understand the universe is very, very limited. Whatever I am saying now are the better estimates that scientists have made. Don't confuse. It is, the universe is almost intangible to us, incomprehensive to us, and whatever we are saying is based on our feeling of the sound and light which comes from the universe. Okay. Now, to the next one. Of course, when with the Hubble telescope we see the image look like this. What we can infer from this, we can see the universe, stars and all in a bigger form. That's all. Maybe if you are looking with naked eye, it is seeing as a 25 paise coin. When you look with a bubble telescope, you may be able to see as a 1 rupee coin or bigger than that. That's all. Only magnification is possible, but not good enough for detailed study. But you can see some slight movements there. That is possible. Of course, stellar movements, some of the stellar movements we may be able to understand by the telescope, but that too with limited sense only. Only if the movement is so recognizable. Normally, with respect to the distance, the movement will be invisible normally. Okay, see the next slide. This is one basis for our study. It is called spectrum shift. And you would have studied about the Doppler, scientist Doppler, he is a physicist. He has established that when something is moving away from us, the sound effect and the light effect are different, because when something is moving away from us, only the long waves can reach us. That means if it is light, only the red waves will reach us. If it is sound, only the long waves of the sound. If you measure the sound spectra, you can understand that when something is moving away from us, the short waves of the sound will decrease and decrease. When something is moving towards us, the short waves will be more and more clear. This whether light or sound. In light, the long waves are, in the Vibgyor spectrum, R stands for the long waves, red, and violet stands for the short waves. So if the light waves coming from a star you are analyzing, you are seeing that more of the red waves are coming to us, then we can establish that it's a star which is moving away from us. So Doppler effect has helped in understanding. This is how we even studied that the universe is expanding. We see that most of the stars have got red spectrum. Whenever the stars have got red spectrum, we can feel that the stars are moving away from us. That is how we always predict that the universe is. This is what the Doppler effect has contributed to studying about the universe. See the next slide. Of course, this is the spectroscopy of the galaxy. Just to explain what the Doppler effect is, we can skip it. I'm not going to the analysis part of it. Next slide. This is also the spectral distribution. We are not going to the physics of that because that will take away the interest in the subject. Come to the next slide. The initial Big Bang theory, so many scientists have made a substantial contribution to the study, and of course Penzias and Wilson were two among them. That is just they have made a big telescope that was not like Hubble telescope. It was a satellite type telescope with a big dish telescope. Anyway, they were some of the people who are involved. Just wanted to show their photo. Next one, please. As the early history of the universe, we don't know really whether matter existed or energy existed. And the present theory of thermodynamics, matter and energy are reversible each other. Matter can be converted to energy, energy can be converted to matter. So we are not sure really what was there first. It is a question like asking whether the hen came first or the egg came first, or like asking whether the coconut came first or the coconut tree came first. We cannot answer that. Both are intertwined, matter and energy. Which form they existed? Okay, we see the next slide. Of course, these are all imaginations. The matter-energy combination was there after 3 minutes. This is just like a story, like what Bible says. In 7 days, the Bible explains how God created the earth, the animals, the flora and fauna, all those things. This is just a story like that. So I cannot attribute any scientific backing for this. People say that initially it was in a plasma stage, then 3 minutes. Who can say this 3 minutes? Because we don't know whether this happened or not. These are all postulates which people imagine. So I'm not basing much on it. Maybe after 3 lakhs years later, the temperatures cooled down, and that is how the planets came. The Earth, the sun, or the such stars got settled. Just imagination. I'm just saying that so many such imaginations are there. Next slide. And of course, the composition of the universe. I told that most of the stars are having the nuclear fusion. Even Sun is having the nuclear fusion, not the fission. So most of the stars are, but fission stars are also there. It is being told that fission stars are also there by scientific observation. So this is also a continuation of that imagination, how the Sun started fusion, how the stars started fusion. No proof, not even scientific basis for this. See the next slide. Now I'm coming to the next topic. Before that, I'll give you 2-3 minutes time to post your questions on this, because this is a session I would like to have interactive. Many people may have doubts because I've exposed to a topic which you may not have thought in the past long. When I was a student, I used to sit on Mauna Vrata, silent meditation for days and days, thinking about the universe. Then I started reading books about the universe. Still, I was convinced that nothing can be understood. And only I stopped that process. So let us see how many of you have doubts on that. Chat box I'm just seeing. If anybody has got any doubt, you can just put it. I'll see the chat box. Any questions? And 2-3 minutes break we can have before we go to the next session, because you have been listening to more than around 40 minutes. Let us see your questions. I'll answer it. There is a correction. Somebody has said that Vande Bharat train speed is 180 kilometers per hour, highest speed. That is for India only. We have got, say, bullet trains in Japan which go up to the speed of 500 to 600 kilometers per hour. There is train connecting Europe, especially Paris and London. There used to be a train connecting almost at a speed of 400 kilometers per hour. So terrestrial speed even more is there. Indians have not come to that stage. That's all. Train speed is high in many places. Okay. So only the Indian speed is then. Any question? Thank you for sharing your knowledge. Then please throw some light on anthropic reasoning and fine tuning. This I'll discuss at the end because it's not for this topic. Let us limit to this topic. We will come to that later. When after every point is discussed, I'll come to that. Okay. Then what about the relation between space, time, gravitation, in the universe? Okay. Obviously, Einstein suggested that there has to be a fourth dimension. Normally we used to have only three dimensions of length, that is of measurement only. But Einstein suggested that there should be another. These three dimensions are of space only. Normally, you take the corner of a wall, there may be three axes, X, Y, Z. That's the space axis. Einstein suggested that there can be a fourth axis for denoting, that is for time. And he even suggested that we can walk back into time. We can go back into time. In some of the Superman movies, you can see these things that people are walking back in time. Einstein suggested that if we can move back speedier than the light means moving back more than 3 lakhs kilometers per second. It's impossible because now the speed, we have not even reached a fraction of that speed. You know that the escape velocity for a planet, for a vehicle to escape from the Earth's surface is only around 11.4 kilometers per second. That is enough. So where is 11.4 and where is 3 lakhs? It's very difficult to reach that level. Anyway, we'll come to that. Of course, this fourth dimension space Einstein suggested, and of course that is why, based on the relativity theory, when we study the axis for denoting any event or any occurrence or any matter, we go for even a fourth axis, which is the time axis. Anyway, I'm not going to much of the relativity theory right now because that is not in the scope of this discussion. I suggest that there's a small book written by Albert Einstein. The name of that book is On the Theory of Relativity. Very small book. If my memory is correct, it is less than 100 pages only. On the Theory of Relativity. So if you want to study this book, I have read long back when I was a student. But if you want to know more about the space and time axis, how the time is considered, how that frames of reference to change, you can go to that book. It gives a very clear and simple explanation of. You may take only one day to read it because it's only 60-70 pages, I think. And go through that book On the Theory of Relativity by Albert Einstein, and of course that will give a very good introduction. Next question is there a possibility of occurrence of a black hole in our solar system? Black hole cannot be there in a solar system because a black hole is formed by a big star, much bigger than the sun. So in the solar system, there is no other star. And of course, the next star, which is nearest to the sun, is around 4.5 light years away, Proxima Centauri. That is 4.5 light years away means it will be 4.5 into 1 year the light travels distance you calculate. That much far away is the nearest star. So anyway, black hole can be far away from that only. So in the solar system, but in our galaxy, there may be many black holes. In our galaxy, we don't know exactly how many stars are there in our galaxy. In our galaxy, from one end to another end of the galaxy if you want to travel. This galaxy is what is called Milky Way or Agashaganga. If you want to travel from one end to the other end, it takes almost 1 lakh light years. Just imagine 1 lakh light years. So light takes to travel 1 lakh years from one end to the other end of the galaxy. It is so big. Our galaxy, Milky Way. Similarly, millions of galaxies are there. In our own galaxy also, there can be dark hole, quite possibly. But nobody has identified so far, because even identifying the dark hole is very difficult, because dark holes do not send any radiation. That is a difficulty. No radiation can escape the dark hole. It only absorbs everything. So if at all a dark hole is there in our galaxy, the chance that it is so close to us is very rare. But cannot predict right now, because the universe is in a turbid motion. The universe is, all the galaxies are in a turbid motion. It can mix up like the water in this ocean. So we cannot say when which galaxy will mix up with which galaxy. But the only advantage is the time frame of the universe is in millions of years, whereas the time frame for human beings are in hours. And of course, when I discuss about the Earth, we will see whether we will survive more than 100 years. Then only these questions do arise. Otherwise, it's not going to be a threat to the human being. Our threat will be our own Earth, not the dark holes which are available elsewhere. Okay. Uh, any other question? I think that's all. Now let us see the next slide.
Have you ever thought about how much longer we humans have left on Earth? It may seem like a silly question to ask. After all, human beings have existed on Earth for roughly 200,000 years, and we've done some pretty incredible things along the way. But Stephan Hawking himself once famously suggested that human beings need to leave Earth within the next 100 years in order to survive. The world's most famous physicist had many reasons for his grim prediction. First and foremost is human-driven climate change. Climate scientists around the world have warned that if we do not control CO2 levels and keep temperatures from warming above 1.5 degrees Celsius over the next 12 years, we could experience significant increases in floods, droughts, and poverty. These things would lead to mass displacement of humans as food and other resources become scarce and as sea levels rise, literally pushing humans inland. These mass migration events are likely to lead to physical conflict and possibly even large-scale wars that could potentially go nuclear. But let's say we are able to save ourselves from catastrophic climate change and avoid a massive nuclear war. Humanity would be able to continue to make technological advances, including in artificial intelligence, which just so happened to be another one of Hawking's concerns for humanity's survival. In 2017, Hawking expressed his fears regarding artificial intelligence, saying that he thought AI may replace human beings altogether. Essentially, Hawking thought that AI will become so advanced that it will begin to self-replicate and even self-improve, ultimately evolving beyond the need of humans. Professor Hawking wasn't alone in his fear of AI. Elon Musk is also famously paranoid of AI, claiming that it could even be more dangerous than nuclear weapons. Now, let's be positive for a moment. Let's suppose humanity is able to not only avoid cooking our planets alive, but also avoid engineering our own downfall by creating AI overlords. Let's go one step further and suggest that we are even able to avoid massive wars, and that, for the most part, we learn to coexist peacefully. If that's the case, we should be able to coast right on through the next century, right? Well, not necessarily. Having a healthy planet, no nuclear weapons, and no artificial intelligence isn't a recipe for guaranteed survival. Just ask the dinosaurs. No matter how well behaved and well managed we are here on Earth, there are threats beyond our atmosphere that could strike at any moment. And Hawking believed that we are overdue for such an event. In his last published book, Professor Hawking explained that the universe is a violent place, full of asteroids flying through space at hundreds of miles per hour. He argued that, considering the last major collision with Earth happened over 60 million years ago, and taking the laws of physics and probability into consideration, it's only reasonable to expect another visit from an asteroid, a visit that would wipe out nearly all life on Earth. In his final years, Hawking gave a slightly more optimistic view of humanity's fate. He changed his doomsday prediction from 100 years to 600 years. But ultimately, he came to the same conclusion. Humanity must become a spacefaring species and leave Earth if we have any hope of long-term survival.
Okay, now let us come back to our presentation. Some observation on the video which I have shown now. Keep in mind one thing, that Stephan Hawking, who was the most renowned scientist of this century, he is no more now. Hawking has said that maybe within 1 century, the inhabitation of humans in this planet will be very limited. He is saying so many reasons. Climate may be unbearable, nuclear weapons may be used, and of course artificial intelligence is developing so that human beings will have robots to work for them. And of course, by all expectations, I think here the anthropic reasoning will work. Last somebody was asking me the question about anthropic reasoning. Anthropic reasoning means study of the statistical observations for interpreting what is next. That is anthropic reasoning. In the case of universe, it will not work, because universe we don't have that much observation. We have got very limited observation. So the anthropic reasoning is almost impossible in the case of universe. But in the case of Earth, it is possible, because we have been observing it for years and years. For hundreds of years, we have observed it, and we have got that knowledge transferred, so we can apply it. And maybe based on that and the heuristics of the scientists, they do predict, especially scientists like Stephan Hawking or thinkers like Bill Gates, to suggest that by the end of the century, the Earth may become uninhabitable, and we will have to resort to machines, robots. For, I think you would have seen the film Yendiran, maybe something like that. We will have to make the robots to survive, and the robots will work everything for us in the adverse condition, because they are not affected by the temperature, nor by the oxygen, nor by the climate. So they can be programmed and they can do everything for us, so that we will remain indoors in a very closed environment. Human beings will be confined to a very closed, contained environment, and that too will be very small in numbers, because only the powerful will survive. The common man will perish. This is going to be the fate of the Earth. So we don't have to worry about how long the planet will survive, because maybe within a century, the continuation of human being as the wildest or as the widely spread species will go down. Instead, only animals and such things who can survive on this Earth in the adverse condition will remain more. Maybe human beings will be there in a very closed environment where they are only controlling machines to do work for them. It can happen. So only a class of people who can afford these things may be surviving. This is one expectation right now. But again, and this may also be based on the anthropic reasoning. We cannot say it is exactly going to happen. Some days everything, and see, for example, the last 6-7 months, the entire lifestyle of the world has changed. So even some more such things can happen, and the entire lifestyle of human beings can again change. So maybe these are things which unexpectedly do occur. See the next slide. And the solar system, the exactly when it happened, when the solar system formed, we are not sure, but it is expected that around 4,600 million years back, that is only an expectation. Solar system formed based on the carbon 12 dating of the rocks available in planet. In all the planets, the condensed rocks are available. It is seen that the oldest rocks are coming in the range of 4,500 to 4,600 millions of years. So we predict that the Earth and such planets are formed only that much back, and that is why the solar system has formed only that much back. Okay, see the next one. Of course, the planetary orbits and its rotation, they do change. Only thing is we are not knowing. Normally, the planets and the satellites orbits in a common plane. That is, it is a coplanar motion, not a 3D motion. It is a planar motion. But when you take collectively all the planets, some slight deviation from a plane may be there. But it is seen that mostly it is very close to a plane. And of course, all of them have got nearly the same orbital spin. For example, if the planets are spinning in almost the same direction, maybe it's a nature's arrangement, nature's specific arrangement that things have been made into a system. There is a systemic approach everywhere in the nature. Otherwise, planets would have collided each other. The trajectories would have collided each other, but nothing such happens. And it is exactly based on a predetermined path. Of course, all the orbits are not circular; they are elliptical. All the orbits are elliptical, and that is why none of the planets are exactly spherical. Most of the planets are spheroid, and some of them are oblate spheroid. Of course, there is a rule that when something is revolving for longer period, it becomes a global shape or a spherical shape. Even a raindrop, when it falls from top, it is not spherical, but over the time of fall, it becomes spherical. That's the nature of the law. Because of the gravitational theory, it happens. Okay. Now let us see the next slide. Of course, the chemical and physical properties of the planets. Most of the planets have got variable combinations, but mostly metallic and semi-metallic materials are there. Especially the very common materials in all of these planets are common metals like iron, aluminum, and then non-metals like silica. These are common in most of the planets. So maybe the original formation of the planets also, this would have been, because these things are existing in most of the planets, and wherever we made observations, missions to Mars, missions to Jupiter, we have seen that the material contents do have almost a similar pattern everywhere. Of course, mostly of volcanic origin. And of course, Earth also had only volcanic origin materials, but later it transformed into soil by weathering action of the rain and sun, mostly rain. But many of these planets which we see around, they don't have rain. So the weathering action by water may not have been there, but the weathering action by the sun is there everywhere. And the farther the planet is from the sun, the weathering action will be the less. Okay. Now see the next one. And many times we have visitors from the cosmos, from faraway places. And these visitors are not coming from other solar system. These visitors are in our own solar system somewhere. But only thing is they change their path. Well, these things are called meteorites, and it is believed that these meteorites would have been formed at the time when the solar system formed around 4 billion years back. These things would have been formed there. That is a belief system. We don't know exactly from where it is coming, but most of these things, by the time they enter the Earth's atmosphere, it gets vanished because the Earth's atmosphere is having air is having friction will burn it. That is why an atmosphere with air is a boon for the Earth, because most of the things which enter the atmosphere will burn by itself, and by the time it touches the Earth, it may vanish. If it has not been like that, many other meteors would have fallen in many other places. But once or twice it happened. The meteors were very big in size. They didn't burn out by the time they have fallen. So one of them we'll see hereafter, which is shown here. Next slide, we'll see. This slide just says that the Greek philosophers, including Aristotle, observed that the sun rising in the east and setting in the west is due to the Earth being the center and sun moving around the Earth. Leave it. That I have told earlier. Next one. And of course, people like Aristotle believed this because of many other reasons. For example, he observed the Jupiter's satellite. Jupiter has got big four satellites: Ganymede, Callisto, Europa, and Io. He observed these satellites, and he suggested based on that they are all revolving around the Earth as a common factor. Anyway, it was a misobservation, because this observation, see, 2,100 years back, it would have been never correct. Let's see the next one. How far things are from us? I told that a light year is the time taken by the light to travel in 1 year. It is given in numbers there. Just see that numbers. 9.46 US trillion. Trillion is million, million, million. Million into million is the US trillion. The British trillion is different. That is why, the US trillion is million into thousand, billion into thousand. That is US trillion. So US trillion is million, million, whereas the British trillion is million, million, million. This is a US trillion what I have given, 9.46 trillion kilometers. That much is the distance traveled by light in one's year. Okay. And such 1 lakh light years is the diameter of the Milky Way galaxy. Just imagine. And we have got many times Cepheids, some small stars, coming very close to the galaxy center, but it can never get into the galaxy because this galaxy is contained by the sun and its planets, nothing else. Of course, meteors and such things are there inside. Okay, see the next slide. And this is about the bandwidth of light which is coming. This you can skip. See the next one. This also I have explained earlier, the redshift of the Doppler effect. When things are coming near to you, the blue shift is there. When things are going away from you, the red shift is there. You will see the next slide. This is what a Hubble Space Telescope will give you the view. It will give you a blurred view of what is there. The stars you can see a bit enlarged. This is a Hubble telescope view. Okay. See the next one. This also I have explained, the red shift. Of course, by Hubble telescope, you can observe the reddishness of the stars and you can understand that they are moving away from us. Next one, please. How these elements originated. The elements might have been original because it is very difficult to make element like silica or element like aluminum. They have been formed earlier. We don't know how it was formed. But in almost all the planetary constituents, these elements are there. You know, the most abundant element on the surface, on the atmosphere of Earth is nitrogen, Earth's atmosphere. But on the lithosphere means the surface of Earth, the most abundant element is oxygen. And next to oxygen comes aluminum. Aluminum is the most abundant metal on Earth's crust, not iron. Iron is much smaller. I don't know how these elements got its concentration, but nobody knows exactly how these many elements were there. Maybe in the initial stage of the Big Bang or the cloud condensation, these would have been there. There is no satisfactory explanation to say why aluminum is more or why oxygen is more. It happened like that. That's all. So there are so many things on this earth we cannot say why, and that is why the man's knowledge is always limited and will be limited till the mankind gets extinct. That is it. Okay, next slide, please. Okay, here it is given. The content of different elements on the Earth's crust. Earth's crust means on the Earth's lithosphere. Atmosphere it is different. Atmosphere, nitrogen is the maximum, oxygen is the second. That's only air. Okay, now see the next slide. Again, this is one belief system that how the solar system evolved with its abundant collection of heavier elements condensed from the gas cloud left after the explosion of the supernova. We don't know. It is believed that the solar system evolved from a gas cloud after a supernova explosion. Again, a belief, like of course, this belief was made stronger by Einstein. See the next slide. Supernova clouds. This is the process what is shown. A supernova explodes, then concentrations of dust coalesce together, and then we have what is called, see the stage by stage, top to bottom. This is how now we believe that the solar system evolved. Not sure. Always keep these are only imaginations. Don't say that it is true like that. Okay. See the next one. The internal layers of the Earth. You know that the Earth has got an outer layer which is called the lithosphere or the crust, and then inside that we call the mantle, and the innermost we call as the core. The core is always in liquid form. Whether the core is of the same diameter, we don't know, but core is mostly in liquid form. So we will see in the next one that. See. This is a cut portion of the Earth. I think this is more biggerly shown in the next slide. We will see the next slide, how this crust will look like. Yes, this is it. You see, the cut piece, like a cake is cut to its center, the Earth is cut to its center and a piece is taken out. The outermost is called the consolidated crust. And below that you have got the inner crust, then the lithosphere part, and going at the centermost portion we have got the core, which is shown reddish. Most of the time the core will be reddish and core will be boiling. And of course sometimes even in the mantle portion the boiling liquid may be there. So core will be mostly boiling. Now let us see the next slide. The outer surface of the Earth is more liquid-like. You know, 2/3 of the Earth's surface is almost liquid, with water varying from 0 to 40 kilometers depth. Of course, the 40-kilometer depth is a very rare locations. Mostly it is a very small depth only. Okay, so that outer surface of the Earth is a liquid layer, and it is like that. Okay. Just wait for a minute. Then now let us see the this cloud, which is the magnetic fields protecting the atmosphere. The atmosphere has got a magnetic field only because air is there. Because of the air conducting the magnetic field, we are feeling it outside. Because if there is no atmosphere, magnetic field become very, very rarefied. But gravitational force will be still there. That is why most of the other planets don't have a magnetic field outside them in this proportion. Only very nominal field is there, but gravitational pull is the same for all of them. Remember, gravitational pull and the magnetic effect are slightly different. Okay, and of course the internal crust of the Earth is also formed typical due to this magnetic field. Let us see the next slide. Once in a while, we have got what is called a solar wind. Solar wind is a sort of magnetic wind which comes because of the sun's radiation having specific attraction to the magnetic field of the Earth. And solar wind, of course, will have some magnetic turbulence on the Earth's surface. It happens once in a while. This comes because the magnetic field created by the sun is affecting directly the changes on the Earth's surface. So whenever some heavy magnetic turbulence is there on the sun, it is also felt on the Earth's surface, which gives rise to what is called the magnetic wind on the Earth. Okay, next one. Of course, in the solar system, there is an asteroid belt. There are so many asteroids, small asteroid cannot be called as a planet. They are small ones. Sometimes some of these may escape the asteroid belt also. Then it becomes dangerous. If an asteroid is falling on the Earth's surface, definitely it is to be dangerous because asteroid will not burn up before it reaches the Earth. It may still remain as solid up to an extent. Now see the next slide. We have some comet impacts. The comets can be, as I told, small asteroids can be comet. Some solid matter which is still revolving around the sun or some other planet which escapes that attraction can be a comet, or some small accumulation, small debris accumulating somewhere on the Earth also can become a comet. And if a comet falls on the Earth, it makes a big crater, big hole on the Earth. And we had so many such comet falls at different places on the Earth. And the biggest comet which fell so far was almost, it has flattened almost 2,100 square kilometers. It was there. We'll see about the comet next. Let us see the next one. This is a comet which has created a lot of difficulty for us. This fell somewhere near Mexico. You can see that that arrow shape is given there. It was somewhere near Mexico, and it was in the beginning of this century, or beginning of the 20th century. It has done a lot of, that's the biggest fall which has happened so far. This can happen anytime. Say, for example, an asteroid is escaping the asteroid belt, which is moving around the sun. It can come to the Earth. It can even cross the other planets also and come to the Earth. Similarly, Jupiter has got a lot of small asteroids moving around it. Small planets are moving around it. Suppose some of them lose the control and escape out of the gravitational pull of the planet, it can come even to the Earth's atmosphere. So this can happen anytime. Any external cosmic body can enter the Earth's atmosphere, and even if it goes very closely, the Earth can attract to inside also. So don't believe that nothing can come to the Earth. Things can come to the Earth. People nowadays believe that outer planet organisms or living beings are coming to the Earth in vessels called UFOs, unidentified flying objects. But that is only a myth. As per the present norms, no other galaxy people can come to our galaxy, first thing. Then from our own galaxy, no other solar system. There are so many solar systems in our galaxy, can escape the sun and come to our solar system. Only our solar system planets one-to-one travel is possible right now. And in our solar system, we don't think that life is existing in any other planet. If it is there, they may be able to come to us. This is the present state of belief by scientific observations. Like the entropy, which we have mentioned earlier. If at all life is there on any other planet on the solar system, they may be in a position to reach to the Earth also by some flying objects or something, like we are going to Mars and we are going to Moon, like that. Okay, but otherwise it is difficult. So this UFO concept is only a threat. Maybe it's our own some space vehicle which is moving around. But people say that they have located it many places. Some even in Hindi there's a film also where a UFO is coming with a peculiar creature like that. This is all myth and belief. That's all. There is no reality behind it. See the next one, please. Of course, that crater which was formed in Alberta by that fall. Alberta is very close to Mexico. Okay, next one, please. That place in Mexico, it was called Chicxulub. There is where that 2,100 square meter impact was, square kilometer impact was there by the, I think it was 1906 or 04. That fall was there, comet fall was there. Okay, leave it. Next one. It can happen even now, anytime. And it is believed that some 60 to 65 million years back, such a big asteroid has fallen on the Earth, and 1/3 of the Earth was devastated. And it is believed that the mightiest species which was there on the Earth at that time. I told earlier that around 60 million years back, there used to be a strong species, the dinosaurs. It is some people say that the dinosaurs got extinct by that fall of the asteroid. No surety, because we don't have any evidence for that. But some craters are found on the Earth's surface, just indicating that there was a big fall, nothing else. Next one, please. And of course, it is also believed that most of the continents were close by earlier. And you see that between the African continent and the American continent, there is an elevated space which indicates that maybe that would have been the common point where they joined. And this entire land on the Earth used to be a single piece, which we used to call Pangea. We will see the next slide. These theories were propagated by Wagner. See, this is Pangea. You see all the land, America, Africa, Asia, Australia, Europe, all these are together as a single piece. And they have moved by tectonic movement, by the movement of the top plates of the Earth's surface. The lithosphere has got strong plates. Strong plates means rigid plates which move to each other. So the Pangea and the Indian part which was there, which got separated as India and Australia, later separated to India and Australia, that was called the Pandalasa, and the entire thing was called the Pangea. See the Pangea, that was a land mass before billions and billions of years back. This is also a belief, because the joints are still visible in the Earth, and that is why we believe that, like I have shown a joint between the American continents and the African continent. Similarly, the living organisms near to the eastern coast of India and the western coast of Australia. This all make feel that Australia and India were together, America and Africa were together, Asia and Europe were together, like that. That we have got almost like a proof. It still stands. Like we say, India and Sri Lanka was close to each other, slightly got separated. Anyway, all these things are the belief right now, but it would have happened. Now, see the next slide. And of course, Harry Hess, during 40s and 50s, mapped the entire ocean, and there only he found that the Pacific Ocean and the Atlantic Ocean has got some signals of separation, that which I have shown earlier. Okay, next slide, please. This is how the molten liquid comes from the Earth's inside core to the outside mantle. This is how it comes, by convection. I am showing an animated picture where the inside molten liquid from the Earth core is coming outside to the lithosphere, and it may escape sometimes, which we call as the volcanoes. If it goes out of the crust, it is called volcano. This is how it comes out, by internal movements. Okay, next one, please. Of course, this is that lines which Harry has identified. They indicate that these were the lines where the continents were almost together. They have separated. He has identified such lines everywhere on the globe. Okay, and he has seen that on these lines, the depth of the sea is very small, which indicates that it would have been a landmass. Right. Now, next slide, please. This is a cross section of the Earth. What I have told, the outer sphere is the lithosphere. It is showing the different continents. Of course, you can see that the cross section of the Earth is also shown there. Okay. See the next slide. A bit more explained one. We can skip this one also. This must be available in some of the geology books, how the Earth's crust is formed. Next one. And this is how he, of course, Harry only told that the continents were connected like this. Now they have separated. Come to the next one. Again, that interconnectivity is shown. And this movement apart is what is called plate tectonics. Plate means the surface of Earth is in different plates. These are the different plates which are given. See, the names of each plate is given. These plates, of course, will move to each other. That is how the continents do separate. That is how we say this is called the continental shift. And Pangea became different pieces by this plate tectonics, movement of the surface plate of the Earth. This is a portion to study in geology. BTech students of civil engineering will study this in plate tectonics in geology paper which they have got. Okay, next one, please. This also we can skip the same thing, more explained. I don't want to go to that detail of it. Again, some separated portion of the plate tectonics is shown. How a particular plate moves with respect to each other. See, this is how the Himalayas are formed. Two plates press each other. When they press each other, the landmass in between will go up and up. It becomes a mountain. This is believed to be the theory of many mountains like Himalayas and the Alps. The plate tectonics, two plates crushing together, going up and up. It is believed that even now Himalaya is going slowly up and up because the plates are still pressing each other. Okay, next one, please. Piecewise it is shown. Whatever I have shown earlier, the plates are shown piecewise as how each piece looks like. Next one, please. This is a three-dimensional sketch of this, how the surface will look like. When the plates press each other, the surface will get elevated. So the plate tectonics seen on the surface. That is this. Okay, next one, please. Now, my last topic today is, did man land on the moon? You will see first two videos, then I'll explain it. And after that, I'll let it to you to decide whether man landed on moon or not. But before this video, I just want to see a query. I just want to see how many of you believe that man landed on moon and how many don't believe. Please chat. How many of you believe that man landed on moon? Maybe after this videos and my explanation, whether your concept will change or not, I'm not seeing now. How many of you believe that man landed on moon? And how many of you don't believe that man landed on moon? Please post in the chat box. Easy to post because you can simply write landed, not landed. Just see. I just want to see what is your feeling or your belief system, whether we landed or not. Let us see. Alan Peter believes, Ashwin Dash believes, Naushad Ali landed, Rizam landed, Teresa Joseph landed, Gayatri DS landed, Selma Mary landed, Ashwari landed, Deebu landed, Baby Tessie, I believe, Devi Krishna PS landed, Abhijit not landed, Bushara landed, Aparna landed, Nitin Raj not landed, Helpsiba Isaac not landed, Shankar landed, Emir Ross not landed, Elizabeth Kurula landed, Shailesh Kumar landed. Parvati Shine not landed. Rakhi Roy landed. Shamili Baiju landed. Okay. So there was a survey among the Americans and Russians. Ramesh Krishnan. So far there has not been apprehensions from scientific community. So I believe they landed. Okay. There was a survey among the common men of USA and USSR. USSR means now Russia. And 28% of the Americans said that they believe the man has not landed on moon. 28%. And in the Russians, 29% said that man has not landed. So now after my session is over, I'll still ask you how many believe man landed or how many believe man not landed. So 2 videos are there. After the 2 videos, I'll have a 10 minutes explanation. After that, I'll let it to you to decide whether man landed or not. Now let us see the video. First one.
That's Neil Armstrong and Buzz Aldrin walking on the moon. Okay, maybe you've seen this clip before, but think about that for a second. They're on the moon, a celestial object nearly 240,000 miles into outer space. That distance is like flying all the way around the Earth 9.5 times. Millions of people around the world watched on July 16, 1969, as Apollo 11, carrying astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins, launched from Cape Kennedy, Florida, and disappeared into the sky. It was the climax of years of preparation and research, and the pinnacle moment of the so-called space race between the United States and Soviet Union, a years-long rivalry to compete for dominance in space exploration. For the 8 days following the launch, the world awaited the return of the would-be heroes. So what actually happened between here and here? So let's start with the components of the ship that were discarded one by one until this became this. Here's the rocket that sent the astronauts into space, the Saturn V. The 3 stages of the Saturn V each played a different role in launching Apollo on a path to the moon. We'll get to that later. On top of the rocket is the actual Apollo spacecraft. It's made up of 3 parts too. There's the lunar module, the component that would eventually land on the lunar surface, the service module, which had propulsion systems for course corrections and entering and escaping orbit, and the command module, where our 3 heroes were for most of the mission. And last but not least, this is the launch escape system, which was designed to pull the command module away from the rocket if something went wrong during launch. Together, all these pieces made up the Saturn V rocket and Apollo 11 spacecraft. But it's the way they came apart that made the moon landing happen. Saturn V's first stage launched Apollo, carrying the spacecraft 42 miles above the Earth and reaching a speed of about 6,000 miles per hour. The first stage then detached, and once the Saturn V's second stage kicked in, the now needless launch escape system jettisoned too. The second stage propelled the spacecraft even farther and faster into space, and after it detached, the third stage of the rocket fired briefly to knock Apollo into a parking orbit 103 miles above the Earth's surface. Here, final checks were made, and the Saturn V fired again to set Apollo on course to the moon, in a move called the translunar injection. Once the spacecraft propelled away from Earth, the Saturn V's job was done. Now, the astronauts needed to pull off a mid-flight maneuver to reconfigure the ship so the crew could access the lunar module, which had been stored in a protective compartment during launch. To do this, the command service module detached and flipped 180 degrees, docking with the lunar module and extracting it. In the process, they ditched the third, now useless, stage of the Saturn rocket. This whole high-stakes launch process only took about 3.5 hours, and this, the completed Apollo spacecraft, was the end result. For the next 3 days, Apollo coasted through space, until it finally reached its target and was pulled into orbit by the moon's gravity. This is where the crew split up. Armstrong and Aldrin transferred to the lunar module, named Eagle, and slowly descended toward the surface, while Collins continued to circle the moon in the command module, called Columbia. Now, here comes another tricky part, landing on the moon. To make this historic moment happen, Eagle turned and used its engine to slow its momentum and ultimately touched down on the lunar surface.
Eagle has landed.
The moonwalk was broadcast live on television, immortalizing Neil Armstrong's words here.
It's one small step for man, one giant leap for mankind.
I think that was Neil's quote. I didn't understand it. One small step for man, but I didn't get the second phrase.
After about 21.5 hours on the moon, Eagle performed the first launch from a celestial body that wasn't Earth, leaving its landing gear behind and timing its descent with Columbia's path in lunar orbit to rejoin the spacecraft. Once Armstrong and Aldrin transferred back into the command module, the lunar module was no longer needed. Just like before, Apollo needed to break out of orbit. This maneuver was called the trans-Earth injection and began the 2.5-day journey home. Upon its entry point into Earth's atmosphere and no longer needing its propulsion engines, Apollo jettisoned the service module and prepared for re-entry, protected by the now exposed heat shield on the bottom of the command module.
Coming back to Earth at 25,000 miles an hour.
Parachutes deployed and Columbia splashed down safely into the Pacific Ocean. And what was once a 3,000-ton behemoth of rocket, fuel, and freight was reduced to this, a small command module floating in the ocean, carrying 3 astronauts and rock samples collected from the surface of the moon.
Now, one more video is there, that is about the launching and falling process on the moon by the moon probe. Let us see that. Then we'll proceed to the explanation. What is happening actually?
The Saturn V rocket that lifted the spacecraft out of Earth's orbit had been reduced to its final stage, the S-4B. The Command and Service Module, or CSM, separated from the S-4B, turned through 180 degrees and docked with the lunar module, or LEM. The now combined CSM and LEM pulled away from the S-4B rocket, proceeding on its roughly 250,000-mile journey to the moon during the translunar coast phase. Almost 3 days later, the spacecraft entered lunar orbit. The crew spent the next 25 hours performing various systems, checks and tests while in orbit around the moon. In preparation for landing, Neil Armstrong and Buzz Aldrin transferred to the LEM, while Michael Collins remained in the CSM. The CSM undocked and separated from the LEM. Now functioning as two separate vehicles, the CSM was redesignated Columbia and the LEM Eagle. Eagle's descent orbit initiation began, followed by the powered descent initiation. After 102 hours and 45 minutes of traveling through space, Eagle became the first manned spacecraft to land on the moon. Once safely on the lunar surface, Armstrong and Aldrin performed a checkout of all systems and prepared for their historic moonwalk. 109 hours and 42 minutes after launch, Neil Armstrong became the first human to set foot on the lunar surface and delivered his famous words, Aldrin joined Armstrong on the lunar surface shortly after, and the pair collected lunar surface samples and conducted experiments. They stayed on the moon for just under 1 day. Eagle ascended from the lunar surface to rendezvous and dock with Columbia, which had been orbiting the moon during the lunar landing. Columbia docked with Eagle, and Armstrong and Aldrin reunited with Collins in the CSM. The LEM ascent stage was jettisoned, and the CSM entered the trans-Earth injection phase to make the voyage back to Earth. The service section of the CSM was ejected before entering Earth's atmosphere. Finally, 195 hours, 18 minutes and 35 seconds after departing the Earth, the command module splashed down in the Pacific Ocean on the 24th of July after traveling a total distance of over 800,000 nautical miles.
Now we have seen two videos. The first video was on the voyage of the moon vehicle from Earth to moon, and second video was on the landing and takeoff from the moon. Now I am telling you some common sense things here which you can try to understand. On Earth we have got what is called a launching pad. It is a very rigid launching pad because even if the angle of launch is slightly varying by a second, not even a minute difference in angle, by a second difference in angle, the mission may fail. So we have got very rigid, long launching pads, launching stations from where the satellite will be launched. It will be launched with the tons of fuel, so that at every stage, there are different stages, one part of the vehicle will get separated and will burn in the atmosphere. After burning its own fuel, it gets detached. Like that, different stages are there. One stage is to escape from the Earth's atmosphere. Second stage is to escape from the Earth's gravitation. Third stage is to escape from the moon's gravitation field. All these stages you have to burn fuel and escape. And Earth, we are having precise launching stations where we can launch the vehicle with utmost precision so that it will reach the escape velocity. That is first thing. And after releasing from the Earth, the satellite goes to around the Earth, and once a particular round is over, it will again burn another fuel tank attached to it, and that will project the satellite beyond the Earth's atmosphere. Then it will go, and if it is lucky, it will reach the moon's gravitation. Once it reaches the moon's gravitation, here also a lag factor is there. If by mistake something goes wrong, it may escape the Earth's atmosphere and it may not reach the moon's atmosphere. That is there. Most of the cases, it will escape the Earth's gravitational field and it will reach the moon's gravitational field. Once it reaches the moon's gravitational field, it will go closer and closer, and the main part of it, the main part of the satellite, will go on orbiting the moon at around 10 kilometers away from the moon. It will go on continuously orbiting. And then a part of it, which is called the moon probe unit. For example, the Apollo 11, which first landed on moon, which claims to have landed on moon, had its propulsion system, which is the satellite, which is Saturn, and it had a moon probe part which was called Eagle. So this Eagle is a part which gets separated from the satellite at a height of 10 kilometers above the moon, and it will fall onto the moon. Say, for example, in Earth's atmosphere, 10 kilometers is not a high distance because most of the aeroplanes travel at 10 kilometers above the Earth's surface because air is still there, air is available. And when it comes close to the Earth for landing, it can easily land because the air friction is used there. But in moon, there is no air, virtually no air. Theoretically, we can say slightly air is there. The entire moon has got around 10 tons of air in it, entire moon. That means it is as good as saying there is no air. There is no air on the moon. And its gravitational pull is also less. It is only around 1/5 of that of the Earth. So when this is falling onto the moon, initially it will be very slow. But all of a sudden, because gravitational pull is there, though it is 1/5 of the moon, just imagine something is falling on the Earth, the air will resist its falling, but moon, there is nothing to resist its falling. So this moon probe unit will fall like anything. And then this unit will try to reduce its speed by burning again fuel. By burning some rockets, it will try to slow down. But if by chance there's a tilt in the angle of the rocket, it will not help. Even a small tilt in the angle of firing of the rocket will make the falling unit unstable. That means it becomes uncontrollable. And that is what is called crash landing. There is no control over it. And 90% of the fall of moon probe units have been uncontrollable, more than 90%. It falls like that. Then what happens is all of a sudden the command will be given for the balloons to open. So all around that unit, balloons will open and it will fall onto the moon ground like a football. And if it is lucky, it will survive. If it is unlucky, it will not survive. You know that the Chandrayaan we sent, it was unlucky that probe unit collapsed totally because the balloons couldn't save it. Sometimes the balloons could save it. So many times the balloon has saved it and the probe unit has worked there. And so it can, if it is having some moving mechanism, it can move over the moon, or if it is having some vehicle attached to it, if you are lucky, and if there are some people on it, they can, if they are lucky, that means 10% chances there, they are lucky. They are lucky, they can come out of it. If they are still lucky, they are in a position to get out of it. If they are still lucky, their equipments may be working and they can travel on the moon surface like that. And then after they travel on the moon surface, they can come back to their vehicle which is there, and if it is landing properly, it will be landing on 4 legs. Like a bird is landing on its 2 legs, it will precisely land on 4 legs. Precisely landing on 4 legs has got less than 5% chance, but it can land. And if it is landing there, this 5% chance suppose we have got, if it is landing there, then they may be able to move on the moon and come back to the satellite. Then coming out of it, they can again fire. The remaining rockets available on the vehicle will be very less in number because 80% of the rockets should have been burned even before that. They can burn the rocket, but no assurance that that rocket will take it to the correct path because there is no launching pad there. For a precision launching, to attach it to a moving satellite 10 kilometers away, it needs 100% precision launching. That facility is not there on the satellite. One may say that once it is launched, it can correct its path by the rockets. But that also there is only 1% chance that the trajectory can be corrected and it can get attached to the satellite. So very, very less chance that something which is randomly launched from the moon can get attached to the satellite which is moving 10 kilometers away in high speed. It is moving. This has to go and attach to it by its correct precision. For example, if Skylab is there revolving the Earth, we fire satellites with rockets to exactly reach the Skylab with precision. Even if it is late by 1 second or something, it can miss it. And this is what has to happen there. Now, there are some questions which I am asking. First thing is, what is the chance of this moon probe landing on the moon on 4 legs? First thing. The landing on the moon on 4 legs, the chance is very, very less because we have to be very lucky. And most of the cases, this even India tried twice, twice it couldn't land. It fell on like anything and it is free fall. Free fall means it will crack into pieces because moon surface will be either rock or soil like thing, and this falling object will crash into many pieces. All the electronic gadgets will be damaged. Even if balloon is there. See, the Indian probe also had balloons all around it, but it didn't work, means it can crash like that. So what is the chance that this can fall on the moon surface safely? Now let us imagine it has landed safely. What is the chance that all the electronic devices in that falling device is intact so that people can move around and work on it? Maybe chances are there. What is the chance that people can get back into this lunar orbiter? There is also chance in it. But what is the chance that this lunar orbiter can launch and attach to a satellite moving on the surface without a precision launching? I am a structural engineer. In my opinion, the chance of such a vehicle being launched without a launch pad and getting attached to a satellite moving around the moon is very, very, very less, almost nil. Okay. Once it gets attached there, maybe the rockets can bring it to the Earth back. One thing. Second thing is, once it reaches the Earth's surface, we have got two types of landing. The most common type of landing is that it will rotate around the Earth, and when it comes to a big water body like the Pacific Ocean or Atlantic Ocean, it will fire a rocket so that this will halt there and it will fall onto it. It falls onto the water, but when it is slightly above the Earth atmosphere, the parachutes will open, and of course when it enters the Earth atmosphere, very heavy temperature will be there. Hundreds of degree temperature will be there, but lining pads will be there. It may protect from the Earth's temperature, but once in a while it can even burn also with the temperature. You know that many astronauts have burned in the air because the temperature was high. But if it reaches the Earth's atmosphere, it can be handled. But these are the difficulties in doing it. So now you have understood what is a moon landing and how it is back. Now I want to see the answer from you. How many of you believe that man landed on moon and returned? And of course, don't ask me the question then how the videos are. A Hollywood director can make a video better than these people, and NASA could make it very well. And all these things happened in 1969. The Apollo 11, which claims to have landed on the moon, started on July 16th, 1969. I was nearing 8 years age at that time. That is it. It claims to have landed on moon on 20th July, and it relaunched from there on 21st July is the claim. And thereafter, Apollo 11 went, Apollo 12 went, Apollo 13 failed. It couldn't go to moon. It returned in the Earth atmosphere itself. Then 14, 15, 16, 17. There were 6 missions. In all the 6 missions, 12 people are claimed to have visited the moon. First thing. Second thing is, at that time, there was no surveillance system available anywhere in the world. Nobody in the world could see, nobody from the Earth could see whether the satellite has gone to the moon or not. In 1972, Russians invented a tracking system for satellites. Thereafter, nobody has gone to the moon. And if that technology was possible in 1969, when even a computer, a personal computer was not available, when the real-time computation or signaling was not done, why can't it be done in 2020 when all these things are there? That is the first question. Second question is, if USA could do that in 1969, India could do many times now, because the scientific capacity of the USA at that time was much, much below the scientific capacity of India right now. And India is even now trying with unmanned robots which can probe the moon's surface. See, and the third thing is, why when the surveillance system came, nobody dared to go. Neither the US nor the USSR. Now, if somebody goes there, we can find from even India whether they have reached there or not. Why after 50 years, nobody is daring to go? The last landing is supposed to be in 1972, they claim. And of course, even in the US, among the scientific community, even there's a saying that, Neil Armstrong and Aldrin were the people who walked on the moon. Collins was just inside the vessel, which they say. And even Armstrong used to many times wanted to reveal the reality, but he was forced by the governance, by the rulers to contain to himself. There are so many such, secrets in this deal, which I don't know. But to my engineer's awareness, to my knowledge, even now, I feel man can land on moon, man can take off from the moon, provided we can install some precision landing facility on the moon. Maybe now Elon Musk is trying for that. Elon Musk has got a plan to offer travel to the moon. If he wills, he may be able to do, because so many missions can be sent to the moon. They can all land in nearby places. That also is not certain. Where you land on the moon is not certain. Maybe suppose you intend to land at a place, you may be landing 100 kilometers away from there. No assurance. In the Earth, we can land in Atlantic Ocean because it is thousands of square kilometers wide. Even if it is 100 or 200 kilometers away, there is no harm. But in moon, it is not like that. Even traveling on the surface for a longer distance may not be possible. But Elon Musk can make it possible, provided a good number of missions can go. They can all work together. They should be ready to stay there for 2 or 3 days, work together, make a launching pad and launch back to the Earth. Maybe one day, I still believe it will be possible. And now my question is, how many of you believe that man landed on the moon? Yes, Gayatri says 12 humans had walked on moon. I also told the same, they claim. I don't say they walked, they claim. Now Shadali Viti says scientific research is for finding truth. Then why telling wrong things? Okay. I don't know who has told wrong things, either me or somebody else. Okay. I feel that scientific research should advance. That on a daily basis, we should be able to go to moon and come. Truly speaking, it is only 3 days journey to and from. So if there is a correct system, 3-4 days we can go and come. By the present satellites, that time they claim to have taken 7 days, but by the present system, even 3 to 4 days we can go and come. Nashad Ali says the scientists are saying wrong things. Okay. Anyway, all of you have got common sense. I am letting it to your common sense. But I still believe that India will go to the moon because we are realistic. We don't make false statements. Moreover, we are a democratic country. It may be sometimes that we may be the first to land on moon. Maybe now Russians are also trying. Now let me ask a blunt question. How many of you still believe that man landed on moon? I've told the story in detail. How many of you still believe that man landed on moon? Let me see. Hepzibah believes, I still believe not landed. Okay, not landed only. In future, I think we can. Yes, that also I am sure. Future we will definitely land. I'm very sure Indians also will land. Time, I don't know. Nitin Raj also saying. Now, anybody who believes we landed? George Matthew, only a story. Okay. Not landed. Rizam believes that we landed. Maybe he will have his own explanation for it. Priti Shankar, I had believed it, but now I don't believe. Okay. Anyway, I leave it to you to think over it because I think many of you are from the engineering background. You are the people who have to make this happen. We are almost on the second half of life, but youngsters should prove that we land. Of course, man could have landed even in 1969 on the moon. There was no technology to come back. If at all somebody landed, they would have given their life for it. But I haven't heard any name who landed and didn't return. All the people who claim to have landed have returned. And they have brought so many samples also. But the this theory, this is called conspiracy theory. Conspiracy theory people say these materials they brought are from the Nevada desert. Nevada desert is still having materials which are similar to the materials which they brought from the moon. Nevada desert is still having those materials. So they say it is like a movie, like a Hollywood movie that these things were enacted because Kennedy wanted to make the world believe that they can do it. Kennedy or Nixon at that time? I think Kennedy, yes. Okay. So Shamili Baiju is just confused. So there are lots of books and papers available on this. Go through. I had a craze one time. I read many of these things. I suggest that you read it because in my young days, when I was a very small child, my mother used to offer prayers to the moon in the evenings by throwing a small thread from her cloth. She will pray for the moon. Some moon prayer was there. I forgot it. But when in 1969, I was studying in the fourth standard. When in 1969, man landed on the moon, we all teased her, saying that now man is on the moon. Then why do you pray with moon? She stopped it. That is only what I remember as the consequential effect of landing on moon. Nothing else happened. So don't get confused. We have to study. I don't say that it is true or false. To my conviction, to my senses, I cannot accept that. Moreover, being a structural engineer, I know the basics of structural mechanism, and I don't believe that man could never ever return from the moon so far. But tomorrow it can because it is possible. We made even the Burj Khalifa Tower. We can make it possible. And one more thing is, even now it is very easy. Any of you can go take a round around the moon and come back. No much risk. Only landing and launching are the risky factors. Going around the moon is very easy. You can go around, take a 4-day trip, go around and come back. Even now possible, it is possible. For the last 52 years, many have gone and come out. Okay, I think no more confusion on that. I think you are enough confused. Many people have left also. Okay. So let us stop the discussion on this much. I have seen your, what is Ramesh Krishna has written, if we can get something positive, at least a motivation to pursue, that itself will be an achievement. Because definitely, I am so sure. Please listen, I am so sure that one day we will all, even Indians will go to the moon. Moon should attract us because it's the nearest thing. It's very close by. The light takes only 1.2 seconds to reach from Earth to Moon. It's so close. Only around 1 point some lakhs kilometers only. Not 1 point, so 3 point some lakhs kilometers. 3 lakhs kilometers is the speed of light in 1 second. So 1 second something. Even the sun, the light takes only 8 minutes from Earth. Okay, so moon definitely we can go. I have no doubt. As I told, even now you can just round around and come back. Don't try to land and launch back. That's all. Okay. So, Ravi Regina, moon will attract our mind and it control the water circulation of Earth. Definitely, moon has got effect on Earth. All the planets have got effects on Earth, and the sun is having the highest effect. Okay. So, thank you all very much. I don't know whether I confused you enough, but any confusion only will make you read better and learn more things. Okay, then thank you very much. We leave today.